Alright, so for problem 8.5-17, it requires you to do all these stuff. I'm not gonna read it, it's too much reading. But yeah, it's another moral circle question. It's basically this version is trying to find the principal stress, so you have to know what that is and the orientations and everything. So I did a detailed video on I believe that was 8.5-7. So yeah, if you need some support on how moral circle is being constructed and some of my opinions, and please go watch that one. So I'm gonna try not to go too much into details when I'm trying to solve this problem. Okay, so construct a moral circle. We know that the x is the this, and y is the stress, tensile stress in the y direction and shear stress in the xy direction, negative, right? Okay, so from here we can tell that this is positive, it's the top right corner, and this is 10 ksi. So this is 10, and this is in the y direction, it's going outwards, so it's positive. This is this, and clearly there's no force tensile stress going in the x direction, therefore so this is 0, right? So by looking at this, we know that this is 0 and this is tau, and yeah, so this is going, let's say 10 in the beneath here. So yeah, let's see. Wait, my bad. Yeah, it's 0. It's going downwards, so it's somewhere around here. And then we go up. Let's see, by how much? By 35.6. So if this is 10, wait, that's a little too. Maybe say this is 10. Okay, so this is 20, 10, 20, 30, 30.5.6, and this is negative 10. All right, because this is the negative and this is the negative tau direction. Okay, this is the positive and this is the negative. Okay, so this is x. Okay, and this is y, right? I mean, if you're a little confused on here, I can't really help you too much. You just have to read the book and know the basics. It gives you the number, plug it in, and then graph it on the graph. I don't have, the engineering paper with me. It's not on the computer screen, so I'm going to do just the estimation. And then let's draw a circle because we have everything now. Let's draw maybe in red light. In red. Sorry, red and circle. Okay, so here we go. Perfect. What the heck? Why is it doing this? This is ridiculous. Okay, let's try this again. Stupid AI. The fuck? This is actually ridiculous. And then we draw like a cross line. So from here to here. Okay. Perfect. Alright, fantastic. So now we draw a circle and the middle line, and now we can try to find out what the average is, right? Which is where across the tensile stress intersection. So it's x plus y, right? The tensile stress x plus y AVG equals this. So what is it? It's 0 plus 35.6 equals 17.8, right? KSI. We got that, and we know that. So this is 17.8 and 0. Okay, now we have to find what R is. So that would be well, we can just use this triangle over here, right? So this would be 17.8 KSI squared plus the x direction, that is, sorry, in the tau direction, that is 10, so 10 square, and square root of the whole thing, trigonometry, basic stuff. This should give you 20.42 KSI, and perfect. Okay, so as you construct a motor circle stress using the motor circle. So we've done A. This is basically, this is A, right? And determine the principal stress and show them on a proper oriented stress element. Okay, so in that case, we're going to do the principal stress. Principal stress is basically, so it's when you spin X, always towards this side. So if we count this intersection as 1 and this intersection as 2, well, stress, right? Because we're on the stress line. It's always X shifted to the tensile number 1, tensile stress number 1. Okay, we always go this direction. If this is X, then it's going downwards, right? We're always trying to hit using X to hit the to meet with tensile stress number 1. Okay, perfect. So now let's try to, and this rotation, it's 2 theta, and theta is the rotation over here, right? It's just when we use the transformation equations, remember the cosine 2 theta and the sine 2 theta? That is because we are transferring that onto a circle as 2 theta, but in reality, theta is just, we have to divide it by 2 after we find out what this angle is. So we transfer X up to here. We don't know what that is, so we're just gonna try to figure it out, the angle over here, and then use 180 degrees and subtract that. Okay, so this is basically just tan, inverse of tan, my bad, of basically 10 over 17, just 17.8. Okay, and the angle should give you somewhere about 29.3. So in that case, so yeah, we have to use 180 degrees minus 29.3. That is going to be 7, 0, so 5, 150.7 degrees, right? And that is how much we have to transfer from here to here. Okay, perfect. Now, and then we have to find the right angle over here, this angle. So usually we call this angle 2 theta P1. Okay, so principal theta, principal 1, right? We transfer up to 1 here. So we have to divide this by 2 because this would be corresponding to this theta over here. Okay, so this equals 150.7 divided by 2. It's going to give you just 535. Okay, so we will have to rotate this by 7. I don't know how much that is. I want to just try my best. This is, yeah, this is 45. Maybe I need to go up just a little bit. 45, 60 something, so 70 something should be somewhere around here. Okay. My bad. No. that's not, sorry, we haven't got that to that part yet. Okay, so we got to this, and then when we look at the principal stress, we basically, when we switch the Mohr circle, what we have right now, into a principal stress, is going to tell us the maximum and the minimum, right? On this circle, you know, tensile strength 1 is the maximum number of stress we can get, the value, maximum value, and this is the minimum value, right? You can just, you know, this horizontal line, this is represent the maximum value that we can get. So on this circle, the maximum is those two intersections, right? You know, tensile stress 1 and tensile stress 2. So that is pretty easy, right? Tensile stress 1 is just the center, which is 17.8 KSI plus R. Right, and then stress 2 is 17.8 KSI minus R, right? Because from the center to the side, you know, on the circumference, that is just a distance of R. This should give you somewhere about 13.22 KSI, and this is about negative 2.62 KSI. Okay, perfect. So we're done with B. And show them on the proper orientation. So yeah, so sorry, yes, and then now we're going to, so this is where we're going to rotate by this much, by 75.35. So you're going to have a square that's something like this, right? So this line has to be perpendicular with this, right? This is going to turn. So once we turn like this, we will have a tensile stress 1 and 2, and this is the maximum that we're going to get, right? The maximum and the minimum. So this is, you know, it's going to be something like this. Or sorry, right? Well, I think, yeah. So after this rotation, it's going to look something like this with a maximum, and this with 0 shear stress. So after we do this orientation, shear stress is 0, right? Because once we get to this part, this and this, right, they're all 0, right? X and Y, they're all 0. Okay, so this is X, X is a 1, 1 is, you know, so this will have by 38, right, something, and you'll have something going in by 2.6. 2 KSI. So the product, and then this is the new X line, and then this is the new, you know, Y line. Is it P, Y, X, P? Okay, because of the principal direction. So now we're done with B, and now let's look at C. Determine the maximum shear stress and the normal stress on the plane of maximum shear, and show them on the sketch of proper orientated stress element. Okay, so for this, it's well, basically, it's going to, the maximum shear stress, this is here, right? Since this is the maximum, this is the shear stress, and this is the maximum we're going to get on a circle, right? So this is max, right? And what is that? This is R, right? Basically, we you know, this is from the center to here. So R, so tau max just happened to be R, which is 22.42 KSI. And when that happens, so when maximum shear happens, everything else is 0. Or 13, well, in this case, it's going to be, sorry, everything is going to be average, right? Theta, AV, G, average, because it's going to spin to here, and then this is, sorry, well, so this is, like, we spinned it up to here, right? This is the X, and this is the Y prime, X prime. And then we're going to spin X, sorry, wrong way. This is going to be X1, sorry, X apostrophe and Y apostrophe, right? Because spin X this way, and now I have to spin X to here, okay? Or here, it doesn't really matter, but we have to spin a certain direction. So it's this is, we already done this, which is 2 theta, and then we either have to add 90 degrees or minus 90 degrees, right? So we can either use the 2 theta P1, add 90 plus or minus 90, or we can use this P1 to plus and minus 45, right? Because we just divided by 2, it's going to get to here. Okay, so we know what this is. I mean, right, we spin it up to here. This is x apostrophe, this is y. We have the straight line, and now we have to get either here or here. Just spin it vertically, right? Because if it's vertical, then we can get the tau max. So, well, this is just, well, 175.35 plus or minus 45. So how much is that? Equals, well, plus 45 minus 45 is going to be 30.35, and then plus 45, this is going to be 235 theta. Okay, and that's plus 45. Let's try this again. Minus 45 is 30 something. Maybe I did something wrong on my paper or on the it's yeah, sorry, never mind. Yeah, these are the other truth. So we got these two numbers, and we know that so when we do a vertical line like this, well, what does that mean? It means that now this is going to be, you know, x apostrophe apostrophe, and then xy apostrophe, right? So these still on the positive, right? And the distance from here to here is just g average, right? It's from here, I mean, sorry, from the center, or sorry, I mean, it's just where this is, right? From 0 to here. This is wrong. It's not from there. That's r. So from 0 to here, that's 17.8 ksi, right? Which is equals the maximum normal stress, you know, S, so probably S1 equals S2 equals, you know, 17.8, right, is what we calculated over here. So now this is everything that we should do for this. We finished the C, and then so what that means is you have to turn this thing by, I don't know, so you have to turn this again by how much? By 30, you know, 30 something, like up to here, or you have to turn 120 up to here, and then it's going to be, I don't know, something like this, right? So the square would be something like this, with x and y being 17.8 and 17.8, and the shear maximum, it's going to be what we calculated to be 20.42 ksi. Okay, so yeah, it's a little complicated. It's you know, it's a lot of information when you're first trying to do this. You know, it's very daunting. It can be, right? But you know, just do more practices. I think I made a mistake on my homework. I basically just solved this problem while I'm making this video. So, you know, just because I did, you know, just do the homeworks, do more practices, and then you will get it. And once you get it, it's you know, everything becomes super easy, and then you just understand it. You know, a circle represents a square, you know, on a plane rotation super easily, super beautifully. It's kind of like learning calculus the first time, right? You know, in the beginning, it's, you know, why do we need it? And then you realize, oh my gosh, this is so powerful, right? It makes things so much easier. So yeah, hopefully this was helpful. Good luck on your studies, and I will see you in my future videos. Bye.